and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on radians, and in this video I'm just going to be explaining what a radian is and talking about a couple of the formulas that we use involving radian measure. So first off then, what is a radian? Well, this is the definition we hear. A radian is the angle subtended at the centre of a circle by an arc whose length is equal to the radius. And what that basically means is, if you draw an arc in a circle with a radius r, what angle do you need to have here so that the arc length here is the same as the length of the radius? And I remember being posed this question by my maths teacher, and I rather lazily said, oh, it's about 45 degrees, because that's what it looked like, and they made me just think a little bit more, and I thought, oh, is it quite close to being 60 because it's similar to an equilateral triangle? And the answer is yes, it is. It's actually slightly less than 60 degrees. And what I've got here is a lovely animation that I found that will show that. So, here we go. There's your radius r, and there's your circle. And what we're going to do is that radius is going to be wrapped around the circumference of the circle to form a sector, and that angle that is then created at the centre of the circle is going to measure 1 radian. Just have a think, how many of those do you reckon you could get in 180 degrees? A little more than 3? Pi. It's actually pi. So there are pi radians in 180 degrees, and we use radians as a different unit of angle measurement for certain areas of mathematics. So what is quite useful to know is some of the relationships between degrees and radians, some of the conversions. So I've just done a quick table on the next slide that just explains those. So 180 degrees is the same as pi radians. 360 degrees is the same as 2 pi radians. You probably saw that on the animation going around while I was talking. Well, based on that then, if 180 degrees is pi, 90 degrees is half of 180, so it must be pi over 2. Same logic, 60 degrees is a third of 180, so a third of pi. 45 degrees is a quarter of pi. 30 degrees is a sixth of pi. And these are the exact results that you're going to see cropping up quite a lot in your A-level maths. What I think is also quite useful for students to have an awareness of, though, is actually what those values are as numbers, because I think sometimes students study radians and they forget that pi is still the number 3.142 to 3 different decimal places. So what I've done in this table is I've just also put in pi over 2 is approximately 1.571, and that knowledge is just going to help you when you come to work on geometry problems and you're trying to work out, well, is that a right angle, is it more or less than a right angle? Having an awareness that pi over 2 as a value is actually 1.571 might be quite useful. So what do we do with these then? Well, we look at the length of an arc and the area of a sector. So what I've got on this slide here is just the sector of a circle, and I'm just going to label it with radius r and angle theta. Now, if you were working in degrees and you wanted to know the length of the arc, you would be using the formula theta over 360 multiplied by 2 pi r. But in radians, rather than 360, you would be using 2 pi multiplied by 2 pi r. And what's going to happen quite beautifully here is the 2 pi there is going to cancel with the 2 pi there and leave you with the formula that the length of the arc in radians is just r theta, literally just the radius times by the value of the angle. Similarly, if you were working in degrees and you were looking at the area of this sector, you would be doing theta over 360 times pi r squared. Now, if again I convert this to radians by changing the 360 degrees to 2 pi, I'm going to get that the area is theta over 2 pi multiplied by pi r squared. I can cancel this pi with this pi here, and the form of the equation that we tend to use is a half, because of the over 2, r squared theta. So that will tell you the area of a sector when you're using radians, and this angle here is measured in radians. So if you join me in the next video, what we'll be doing is a geometric problem that involves using these two formulae because we're dealing with radians. I'll see you then.